Good day, guys. So for this day, we are going to tackle about types of database and file system. So that's under Unit 2. Now for this lesson, we are going to answer the following. First question is that how can we differentiate the types of database system? How do we differentiate the database file system? And what are the advantages and disadvantages of the said file system? For our intended learning outcomes, we must know the different types of database and file systems, their uses, advantages, and disadvantages at the end of this lesson. Now, going to the lesson proper, there are different types of database. The first one is according to the number of users. Now, based on the number of users, we can say that a database can be classified into a single user database or a multi-user database. Now, for the single user database, it only supports one user at a time. Okay? It only supports one user at a time. A single user database that runs on a personal computer is called a desktop database. So take note, a single user database running on a personal computer is called a desktop database. An example is a personal computer, smartphone, a game console playing a standalone game. So those are the examples of desktop databases. Now, looking at this figure 6, we have a single user database setup. In this particular setup, you can see that the user is accessing a particular computer. In this case, if I'm not mistaken, this is a laptop. Now, the user accesses a config database, and then the config database accesses a customer database. Now, when that particular user accesses the config database, it can generate documents, templates, reports, or export data. One or another example that I can give you is the database used by games running offline. So any type of games that runs offline, we could categorize them as standalone or single user or desktop database. Okay. Basically, they are single user database because only one particular user can access that database while he or she is using that particular device. A multi-user database, on the other hand, so multi-user database, on the other hand, supports multiple users at the same time. Multi-user database supports a relatively small number of users, usually fewer than 50, for a specific department within an organization. It is called a work group database. Okay? When a particular multi-user database supports a small number of users, usually fewer than 50, or only a specific department within an organization, we call it as a work group database. Now, if the database is being used by more than 50 users, usually hundreds, across multiple departments, that database is called an enterprise database. What are examples of enterprise databases? Examples are databases of banks, insurance agencies, stock exchanges, the databases used by supermarkets, etc., etc. Now, a multi-user database can be as simple as a Microsoft Access database, or it could be as complex as the databases used by complex operations such as the ones used by Amazon. Particularly if you have heard of Amazon Web Services, they are using multi-user databases. Facebook is using multi-user databases. Okay. In this figure, figure 7, we have a multi-user database setup. As you can see, multiple clients are connecting to the database via the network. Now, the network can be a local network, could be through the internet or through the cloud, which in turn accesses the actual server with database management system, which accesses the actual database. So as you can see, the clients request data, which is signaled by this red line, and then the one that returns the data is the server with the database management system. So it is symbolized by the green arrow. So the DBMS pulls up the data from the database. Using DBMS, it could send and request the data to and from the database. Okay. Databases can also be categorized by location. So when we say a database that supports data located at a single site, it is called a centralized database. Okay. When the database is located on a single site, centralized database. The centralized database can be represented by figure 8. Okay. In this figure number 8. So the server or the database is the big circle, whereas the connected clients are the small circle. Centralized systems are systems that use server architecture where one or more client nodes are directly connected to a central server. This is most commonly used type of system in many organizations where the client sends a request to a company server and receives the response. An example of a centralized database is the one being used by Wikipedia. Consider a massive server to which we send our request and the server responds with the article that we requested. Suppose we enter the search term junk food in the Wikipedia search bar. This search term is sent as a request to the Wikipedia servers, mostly located in Virginia, USA, which then responds back with the articles based on relevance. In this situation, we are the client node. Wikipedia servers are the central server. Now take note, Wikipedia servers. Basically, it is in plural form, meaning to say Wikipedia has more than one particular server. Now, why is that so? Looking back to the figure 8, this particular server or this large circle, which represents our server, okay, could be made up of one or more multiple servers. Okay. If you are familiar with the concept of RAID, when you are setting up your hard disk, so we have RAID 0, we have RAID 1. Okay. Basically, it's the same concept for servers. Sometimes servers, although they are only deploying one particular data or one particular type of data, they can be found or data is stretched out into multiple servers so that number one, they can serve faster. And number two, in the event of failure, one of the server might fail. The other servers can respond or can substitute for the broken down server. Okay, so in this example, our server could be made up of multiple servers, just like in Wikipedia. Now, what are the characteristics of a centralized server? Number one, presence of a global clock. As the entire system consists of a central node, a server or a master, and many client nodes, a computer or a slave, all client nodes sync up with the global clock, the clock of the central node. Now, why is this important? Because all of the clients are connecting to one particular server, all of the clients must be in sync with that particular server. If they are not in sync, what will happen? There could be problems with the data being requested, being updated to and from the central server or the database. Okay, so it is very important that we share one particular global clock. So in this case, the clock does not only pertain to the time, but they also pertain to the other features of the server. Next, one single central unit. One single central unit which serves or coordinates all the other nodes in the system. As I have said, the single central unit may be comprised of multiple servers. They may be more than one, but they are only acting as one central unit. Their purpose is only one. Okay, one single central unit. Next, dependent failure of components. Central node failure causes entire system to fail. This makes sense because when the server is down, no other entity is there to send or receive response or request. Now, you may be asking, sir, why did you told us earlier that there are multiple servers that if in case the one of the servers break down, one server might take the place of the one that is broken down. Now that is correct. Now, this third characteristic does not contradict what I have said. As I have said, this multiple unit serves as one single central unit. One analogy that I can give you is the computer processor that is found in your cell phone or in your laptop or in your computer. Take note, right now, the maximum cores that can be found inside a single processor is how many? If I'm not mistaken, around 32 or 64 or even 128. Okay, for Intel or for AMD. Now, in your cell phone, you could have an octa-core setup, but in that octa-core setup, how many units are only working at a particular task? There's a concept that we call big little architecture, wherein if you are running intensive tasks such as games, we are using the big cores or the higher frequency cores. And if you are running the lower cores, the lower tasks, such as maybe web browsing, we are using the lower cores. Okay. Now, this concept applies also to servers. Now, as I have said, they may be multiple units, but they are acting as one. Okay. So take note that if that one central unit, which may be composed of one or more multiple server, fails, okay, all the clients that are connected to that particular system will also fail. Why? For example, if Wikipedia servers are down, can you make a client request to Wikipedia? No, you cannot anymore because the server or servers or all the central unit of Wikipedia is down. So that is the concept of dependent failure of components. Okay. Next, scaling. So how do we scale? How do we scale a centralized system centralized system database? Only vertical scaling on central server is possible. Horizontal scaling will contradict the single central unit characteristics of this system of a single central entity. Okay. Only vertical scaling. So basically, when you say vertical scaling, you can put up multiple servers. Okay. However, that server is connected in what kind of circuit, if ever we are going to compare it to a circuit? Is it a series circuit or is it a parallel circuit? Okay. If we are going to, okay, so it will be a series circuit. Why? Because we can add layers and layers of servers, but their only purpose is one. Okay, they will only act as one. And when a failure is done or is made on the single central unit, no function should be allowed or no processing should be allowed. So vertical scaling. Another definition for vertical scaling is the addition of resources such as CPU or memory on that particular unit. Now, vertical scaling happens wherein all the resources are pulled into one particular purpose. Now, they are located in one single area or one single computer or one single server or multiple servers, but in one location that is interconnected. And then in vertical scaling, only the processing, memory, or storage is increased. Okay? We are not increasing the number of servers located in different locations or located in different areas. Now, vertical scaling affects only the CPU, memory, or the storage of a particular server, whereas horizontal scaling, on the other hand, cannot be applied to a central server because when you say horizontal scaling, you are basically adding physical servers on multiple locations that accesses different resources. So basically, on a vertical scale, you are actually just using or you're actually just increasing your CPU and your memory, whereas on horizontal scaling, you are increasing your presence, increasing your availability, and increasing your reliability, okay, through the use of multiple physical units. So that is vertical scaling. So vertical, so no matter how high, you are only one building, whereas horizontal, okay, you are putting up multiple houses. Okay, vertical scaling, horizontal scaling. Now, what are the components of centralized system? Now, the components are a node. So the node could be a computer or any mobile device that can connect or any device that can connect to and from our server. The next is server, and then is the or the communication link. So communication link could be the cables, the Wi-Fi, okay, or the fiber optic line, okay, satellite dish, etc., etc. Architecture of a centralized system. Client-server architecture. The central node that serves the other nodes in the system is the server node, and all the other nodes are the client nodes. So the central server is the central node, okay, and all the connections or all the other circles are the client nodes. Now, what are the limitations of a centralized system? Number one, they can't scale up vertically after a certain limit. Okay. After a limit, even if increase the hardware and software capabilities of the server node, the performance will not increase appreciably, leading to a cost-benefit ratio of lesser than 1. So there is a certain maximum limit in which you can upgrade your centralized system. Next, bottlenecks can appear when the traffic spikes. So because they are only located in a single location, second, they are only acting as a single processing unit. The server can only have a finite number of open ports to which can listen to connections from the client nodes. So when high traffic occurs, like a shopping sale, the server can essentially suffer a denial of service attack or distributed denial of service attack, a DOS or a DDoS attack. So that usually happens when you only have one or a centralized system. Now, what are the advantages? So easy to physically secure. It is easy to secure and service the server and client nodes because of their location. Smooth and elegant personal experience. A client has dedicated system which he uses, and the company has similar system which can be modified to suit custom needs. They have dedicated resources, so memory, CPU, storage, more cost efficient for small systems up to a certain limit. They take less funds to set up and have an edge when small systems have to be built. Next, quick updates are possible. Only one machine to update or one uh, central unit to update. Easy detachment of a node from the system. Just remove the connection of the client node from the server and you're done. Nodes are detached. Okay, so you imagine, for example, you have a laptop and then you turn off the Wi-Fi. Basically, you cannot connect, and other people cannot connect to your laptop. Now, what are the disadvantages? Highly dependent on the network connectivity. The system can fail if the nodes lose connectivity as there is only one central node. There's no graceful degradation of the system. So it will suddenly just deny service once there is a problem. Less possibility of data backup, yes, because it is only located in single location. If the server node fails and there's no backup, you lose the data straight away. As I have said, that's why Wikipedia is using multiple servers. Difficult server maintenance. There is only one server node, and due to availability reasons, it is inefficient and unprofessional to take the server down for maintenance. Updates have to be done on the fly, which is difficult, and the system could break. Now, what are the applications? Number one, application development. It's very easy to set up a central server and send client requests. Modern technology these days do come with the default test servers. For example, Express server and Django server. Data analysis, easy to do data analysis when all the data is in one particular location and available for analysis. And it is also used for personal computing. Now, where can we use centralized systems? Can use them in centralized databases, single player games like Need for Speed or Vice City. Entire game is found in one system. Okay. Application development by deploying test servers for easy debugging, deployment, and simulation. Okay. And for personal computers. Now, organizations using them, aside from Wikipedia, are the National Informatics Center of India and International Business. Now, a database in which every node makes its own decision. The final behavior of the system is the aggregate of the decisions of the individual nodes is called a decentralized database. Okay. When we say a decentralized database, basically we are talking about, as you can see on figure 9, it contains more than one particular server or one particular processing unit, and then the aggregate decisions of the individual nodes will be the final decision. So it's like a referee in a boxing match wherein there are three referees, and if the majority of the referees agree to a decision, that will be the result of the match. Okay. So still, when it comes to decentralized database, it still has access to the client, as you can see here. However, the server which houses the data are not just one, but it is more than one. Okay, these are the servers that will make the decision. Example. So the perfect example would be Bitcoin or cryptocurrency. So Bitcoin is the most popular use of a decentralized system. No single entity or organization owns the Bitcoin network. The network is a sum of all the nodes who talk to each other for maintaining the amount of Bitcoin every account holder has. Basically, if you are not familiar with the concept of Bitcoin, certain computers act, or in cryptocurrency, certain computers act as a server wherein they copy the data which is found on another computer. And then if another computer is connected or is connected as a server, it will again copy the data. Now, in order for you or in order for them to come up with the real value or the real amount, for example, I am holding 1 Bitcoin and or 2 Bitcoin, and I already used up or paid use Bitcoin, one of my Bitcoin as payment. So how many will I have? I will only have one. What happens is that the data found on one computer writes that I have only 1 Bitcoin, and then that particular data should also be sync or in sync with computer or server number 2, which in turn should also be synced with computer number 3. Now, what happens is one of the computer is not synced. What happens is that whoever has the majority, for example, server 1 and server 2 acknowledges that I have only 1 Bitcoin, whereas server 3 acknowledges that I still have 2 Bitcoin. Because of the majority or the aggregate values of the two servers, server 1 and 2 against server number 3, which is 2, what happens is that it will be reflected in my Bitcoin account that I will only have 1. because the majority states, or the majority of the servers states that I only have one Bitcoin left. Okay, so I hope that makes things clear. If not, could drop me a question on our discussion page. Characteristics of a decentralized server or system. Basically, this is just a reverse of the characteristic of a centralized server. Lack of a global clock. Okay, so they have different clocks that they run and follow. They are independent of each other. Okay, every node is independent of each other. They have multiple central units, which comprises of multiple computers, nodes, or servers. They have more than one central unit which can listen for connections from other nodes. And they have dependent failure of components. One central node failure causes a part of the system to fail. So if one particular central node fails, that is the one that is only affected. All the other connected systems are not affected. Okay. Vertical scaling is possible in a decentralized system. Each node can have or can add resources, hardware or software to itself to increase the performance, leading to increase in performance of the entire system. So what is nice here is that one particular server can upgrade and then the other one could maintain its current configuration, but at the end of the day, the two can still talk. Okay, no matter if, for example, this server is using an Intel processor, this server is using an AMD processor. This one has 4 cores, the other one has 32 cores. There's no problem with that one. We could upgrade each node vertically. Okay. However, we still cannot do a horizontal scaling because horizontal scaling will lead to issues. Okay. One, because in a decentralized system, we have multiple central units, okay, or multiple processing units. However, they process the same data. Okay. They just copy each other from their location. Okay. They are not processing different data. They are not accessing different data. Basically, when one change happens, the other node or the other server is required to copy the changes made on the other nodes. Okay. Components of the decentralized system are the node, which are the computers or the devices, and then the communication link. Now, what is missing here from a centralized system? Now, from the centralized system, we have a main server. So that is the only one that was removed, the main server. So basically, all the nodes can act both as a server and a client. Okay, so that's why cryptocurrency is a very complicated topic, although it's a very good topic. However, if you have noticed, certain people mine cryptocurrency once they have their own hardware, okay, because they can add resources to the system. Now, the system in turn rewards them with the cryptocurrency or with a certain number of cryptocurrency based on the service that they have done for the maintenance and longevity of the cryptocurrency network. So it's a very complicated topic, but That is how a decentralized system works. So no one or no unit is considered as a server, but all of them are servers. However, they are processing all the same state. What are the architecture used for the centralized system? Could be a peer-to-peer architecture if you are downloading torrents. That is an example of a peer-to-peer architecture. All nodes are peers of each other. No one node has supremacy over the other nodes. Master-slave architecture. One node can become a master by voting and help in coordinating a part of the system, but this does not mean that the node has supremacy over the other node. Now, as I have said earlier, certain people invest in putting up hardware for cryptocurrency, which in turn supplies further resources to the server. Now, in this instance, what happens is that, quote unquote, this person mine, okay, mine in the sense that the system will reward them with certain amount of cryptocurrency based on the resources provided by the hardware that they have set up for the node or for the system. What are the limitations? Number one, it may lead to a problem of coordination at the enterprise level when every node is owner of its own behavior. So it is difficult to achieve a collective task, not suitable for small systems, and there is no way to regulate a node on the system. There's no superior node overseeing the behavior of subordinate nodes. What are the advantages? Minimal problem of performance bottleneck. The entire load gets balanced on all the nodes. High availability. Some nodes are always available online, leading to high availability. And remember, they share the same data. That's why when one is down, you can just access the same data on the other one. And then when the down server is online again, it will just copy all the data from the working nodes or servers. More autonomy and control over resources because they have their own behavior. They lead to more control over their resources. For example, you have a good machine, you have a fast server, you can provide more resources to the system. So what are the disadvantages? It is difficult to achieve global big tasks, no chain of command others. There's no regulatory oversight. Difficult to know which node failed. Difficult to know which node responded. Okay, so that's why hackers are always hacking Bitcoin and other cryptocurrency because it is very hard to track, okay, what happened to their money or to their Bitcoin or to their cryptocurrency. Applications of the centralized system, private networks, so peer-to-peer like torrent or Tor networks, cryptocurrency, as I have said, use cases where we can use them, blockchain, decentralized databases, wherein entire database is split in parts and distributed in different nodes for storage and use. For example, names starting from A in one node, L to N in second node, O to Z in the third node. And then lastly, cryptocurrency. A database that supports data distributed across several sites is called a distributed database. So in this one, all the nodes are the server. So basically, the tasks, the resources are distributed, and then it is highly available as long as there is a node that is available, okay, to service your request. Example is Google. Google search system, each request is worked upon by hundreds of computers that crawl the web and return the relevant results. Google appears to be one system. However, it is actually comprised of multiple computers working together to accomplish one single task, which is to return the result to the search query. So basically, Google has multiple servers set up in multiple locations across the world. So there are times when you are in a particular part of the world or in another country wherein the performance of Google is very fast, or there are certain areas wherein the performance of Google is very slow. Now, distributed systems distributes the data on each and every location. That is why there are instances wherein the service is good and sometimes the service is not that great because how far you are from the particular node or server of that area. What are the characteristics? Concurrency of components. They apply consensus protocols to agree on the same values, transaction, commands, or logs. It lacks global lock. They maintain their own clock. They're independent failure components. If one system fails, it does not have a significant effect on the entire system. If one node fails, the entire system sends the failed node continue to work. In a distributed system, horizontal and vertical scaling is possible. Now, what are the components? Node and communication link. It's almost the same as that of a decentralized system. Architecture of distributed system should be peer-to-peer or client-server. Okay, what are the limitations? Difficult to design and debug algorithms. No common clock causes difficulty in the temporal ordering of events or transactions. It is difficult for a node to get a global view of the system. What are the advantages? Low latency in the centralized system. I have said because they are spread out to different locations. Disadvantages, difficult to achieve consensus, and conventional way of logging events by absolute time they occur is not possible. Okay, because of the location of the different nodes or servers. Application, cluster computing, technique in which many computers are coupled together to work so that they can achieve global goals. Guys, one good example of cluster computing is what they did with the PS3 network. You could kindly research that. They used the power of the PS3 network to actually help in one particular medical project. I do not know if that was the Human Genome Project. Kindly look that up. It was a very nice project simply because the PS3 was composed of different cell processors. So it was not just composed of a single processor, it was composed of multiple cell processors. The architecture of the PS3 was very unique during the time it was released. And then also, if you are familiar with what is happening right now, you could actually share the computing power of your video card in order for the scientists to research on the breakthrough medicine for COVID. Okay, so that those are examples of cluster computing. So multiple computer act as if they were a single computer. Then grid computer, all the resources are pulled together for sharing in this kind of computer, turning the systems into a powerful supercomputer. Okay, that is for example. Then for the use case, SOA-based systems, and then multiplayer online games. So I'm not quite familiar with SOA-based systems. Kindly research what is SOA-based system. MMORPG, I know you are all familiar with that one. Organizations using Apple, Google, and Facebook. Now, databases are also classified according to how they will be used. and on the time sensitivity of the information gathered from them. A database that is designed primarily to support a company's day-to-day operation is classified as an operational database or a transactional or production database. Data warehouse focuses primarily on storing data used to generate information for making tactical or strategic decisions. And then we can also classify database according to the degree to which data are structured. We have unstructured data, which are data existing in their original or raw state. We have structured data, which are the result of formatting data, which is used to facilitate storage, use, and generation of information. And then we also have semi-structured data, which have been processed to some extent. Okay. For example, the website or a web page HTML markup, that is an example of a semi-structured data. XML or extensible markup language is special language used to represent and manipulate data elements in textual format. XML database supports the storage and management of semi-structured XML data. Okay, thank you. Now, we will go to the concepts of database design and the different file systems. When we say database design, we're referring to activities focusing on the design of a database structure that will be used to store and manage end user data. A database must meet all user requirements that does not just happen, its structure must be designed carefully. Okay, so the database must be designed carefully. It is not something that just pops out in air. It must be planned and executed properly. Now, what are the different files of file systems? We have the manual file system, which is, for example, pen and paper, paper and pencil system. So it's accomplished through a system of file folders and filing cabinets. As long as data collection was relatively small and an organization's business users had few reporting requirements, the manual system served its role as a data repository. We also have a computer file system. So initially, the computer files within the file system were similar to the manual files. When businesses users wanted data from a computer's file, they sent requests for the data to the data processing or DP specialist, which had to create programs to retrieve the data from the file and manipulate it to whatever manner the user had requested and present it as a printed form. DP specialist was hired to create a computer-based system that would track data and produce required reports. So basically, a computer file system is something that is in your computer. So, for example, you create multiple Word documents and then you store them in multiple folders. So that is a computerized file system already. Okay, so back in the day, they were using punch card or magnetic tape in order for them to process computer data. However, they need to hire a specialist known as a data processing specialist in order for that data to be presented in report form. Now, what are the basic file terminologies? We have data, which are raw facts. So it could mean or it could have any value such as telephone number, birthday, customer name, etc., etc. It has little meaning or value unless it is organized in a logical manner. We also have the field. Okay, a field is used to define and store data. It is a character, a group of characters that has a specific meaning. We also have a record, wherein they are a logically connected set of one or more fields, such as a person, place, or a thing. And we have a file, which is a collection of related records. For example, a file might contain data about the students enrolled at gigantic university. What are the problems with the file system data processing? What are the reasons why we use a database management system? Now, the problems with them are the following: lengthy development time. Okay. The first and most glaring problem with the file system is that even the simplest data retrieval task requires extensive programming, difficulty of getting quick answers. Okay. They need to write programs to produce even the simplest reports. Complex system administration, you all know because they are stored in multiple files or folders. Administration is very, very difficult. Lack of security and limited data sharing because, for example, a file stored in a file folder, anyone who has the key or the lock can get that particular data. Okay. Also, for example, you cannot share across multiple locations to multiple users. If you share that particular data, it can pose a lot of security risk for the data or for the company using the data. And then lastly, it requires extensive programming. It's very, very time consuming to program for a file system. ACID properties in database management system. So when we say ACID properties, what do we mean by ACID? It is actually an acronym. So we have here an example. Suppose Alice has an account with an amount of $150. There is Bob's account having $50. We are transferring the amount of $100 from Alice to Bob. Now we can see how we can ensure data reliability using ACID properties in database management systems. Now, file systems does not have ACID properties. ACID properties can only be found or can be seen in database management systems. Now, the first one is atomicity. When we say atomicity, basically all or nothing, meron or wala. Okay? There is no other option, all or nothing. If you're doing any database transaction, all the operations should be executed. Otherwise, no operation should be done. Okay? Basically, it's telling us that all the operations should succeed. If one or more operations of the same transaction does not succeed, all of those operations will not be executed or will be rolled back. All operation in the transaction is considered to be as one unit or atomic. Okay? If the system fails any read or write conflicts during the transaction, the system needs to revert back to its previous state. For example, we deduct the amount of 100 from Alice's account. We add 100 to Bob's account. All operations in this set should be done. If the system fails to add the amount in Bob's account after deducting it from Alice, we revert the operation on Alice's account. Or we put back the $100 back to Alice's account. Okay, that is atomicity. Consistency. Every attribute in the database has some rules to ensure the stability of the system. The constraint put on the data value should be constant before and after the execution of the transaction. If the system fails because of invalid data, the system should be rolled back or reverted back. For example, the total amount in Alice and Bob's account should be the same before and after the transaction, meaning should be total of $150. The sum of money in Alice and Bob's account before and after the transaction, sorry, it's 200. So if so this transaction preserves consistency acid properties in DBMS. So because Alice has 150 and Bob has 50, okay, after the transaction of moving $100 from Alice to Bob, the total of $200 should be the same. Okay, should not change. If there is a change in the total transaction, then we should roll back the entire transaction. Okay, that is consistency. If you started with the 100 or 200, you should end the total transaction with 200. Isolation. If you are performing multiple transactions on a single database, operation from any transaction should not interfere with the operation in other transactions. The execution of all transactions should be isolated from other transactions. Okay. For example, if there is any other transaction between Mac and Alice, it should not affect any transaction between Alice and Bob. Both transactions should be separated or isolated. So that is I. Last, durability. All the three properties, all the above three properties, such as atomicity, consistency, and isolation, should be satisfied while the transaction is in progress. But durability issues can happen even after the completion of the transaction. So this is the acid property after completion of transaction. The changes made during the transaction should exist after completion of the transaction. Sometimes it may happen as all the operation in the transaction completed but the system fails immediately. In that case, changes made while transactions should persist. The system should return to its previous stable state. For example, Alice transferred $100 to Bob's account. So at the end of the transaction, Alice has $50 while Bob has 150. The total amount should still be $200. Everything was successful. And then afterwards, the bank or the computer or your laptop suddenly experiences disconnection. Durability states that all of the successful changes that has happened should remain and should stay. That is durability. All the successful transactions that has already been approved should remain. Okay? Even if there's a power failure, all the changes should remain. There should be no changes after the connection or after the power has returned. Example, it may happen a system gets crashed after completion of all the operations. If the system restarts, it should preserve the stable state. An amount in Alice and Bob's account should be the same before and after the system gets a restart. ACID properties in DBMS makes transactions over the database more reliable and secure. This is one of the advantages of the database management system over the file system. Okay, thank you. So that is the end of our Unit 2 lecture about file systems and the different types of database. Thank you.